Okay, guys, so a very good morning to all of you. Uh, today's we are going to discuss about this is lecture number 5, and in the last from the last two lectures we were discussing about the electrochemical machining operations. Okay, so in the last lecture, basically, I just discuss we just discuss about the some of the formula, or we can say how the material removal rate is formed. Okay, so that formula we have seen through that. Okay, a simple formula for that is I A by rho FV. Okay, so this is like A by V is basically the electrochemical equivalence. Okay, that A by V, and this rho is basically the density. So for an example, like if you are talk like what we have discussed, that this is only a single kind of material, like when we were deriving this material removal rate. So for an example, that if we are taking the iron, then there is a no issue, because density that we will consider, that will be for the iron only. The electrochemical equivalence, which is basically the ratio of A by V, that is atomic weight and the valency. So that will also be defined for a material. So if we are taking it is the iron, then this atomic weight will be 56 around, or 55 point something, 55.85 around, and the valency will be 2. So let's talk about the alloy. Okay, for an example, if we are taking the alloy, then what will happen? So this A by V ratio will change, or the density will also be changed. So how we will calculate that density? We have this we calculated this formula, that is that three elements, if there is a three element of the combination of for alloy, then we can consider that A1 V1, that is the atomic weight in the valency for the first element, second element, third element, like that. And the density of that is rho 1 A1, rho 2 and rho 3. Okay, and also that is the important criteria that we have to keep in mind, that is how much percentage of that we are taking into consideration. Okay, so for an example, if we are considering it as a x1, x2, x3, like 50%, 25%, then we can consider it as 100% that has been formed. Okay, the combination of these three elements, alloy is formed. So now if you want to calculate, sorry. Okay, so for an example, if you want to calculate the equivalent density, then we can go through this formula. Okay, guys, any one of you is speaking, so do you have any doubt? You can ask me. Okay, so here we can calculate the Jafar Makbul. So guys, if you have, sorry, from here basically we can calculate the equivalent density. Okay, similarly, like for the chemical electrochemical equivalence, we can use this formula, that is 100 by E equivalent, that will be equals to x1 percentage of the first one upon plus x2 percentage of the second one upon E2, like that we can calculate. So 1846, do you have any doubt?
नो सर, नो सर, अभी ज्वाइन किया इसीलिए माइक ऑन हुई।
Okay, okay, okay. Okay, guys. So then, so here I one of the most important that I have to mention, that is, like if you are taking this 100, then it should be whatever the percentage that you are taking. If it is a 50%, for an example, then you have to write it over 50 only. But if you are considering it as a one, then you should write this 0.50. Okay, so this that like 50 by 100. Okay, so that you please keep in mind while doing the calculation part in the numerical problems. Okay, another thing that we calculated, this is that is the resistance gap. Okay, or the gap resistance, we can say. So that is represented by the capital R, and here the small r that we are taking, that is specific resistance or resistivity, we can say. Okay, distance resistance also we can say, that is calculated in the ohm into centimeter, that length is there. H is basically the minimum gap that we have to maintain between the electrodes, okay, the anode and the cathode, that we can say, or in other terms like workpiece in the tool, we can say. And S is basically the surface area, or we can say in other term, that is a cross sectional area. So that is nothing but the how much area through which we are removing the material, that we can mention. Okay, After that, basically we derive two more formula that is based on the flow analysis, which is based on again the electrolysis part only. So how it is based on that, how to calculate that, that is the how much amount of the heat is generated. So first we can as well as how much amount of the heat is absorbed by the electrolyte. Okay, because when we are supplying through the power supply, when we are initiating the potential difference, that time the completely the heat is generated by this potential difference, by creating the potential difference. And we are assuming that 100% of the energy, because everything is happening in the electrolyte, and whatever the amount of the temperature with whether it's a temperature, whether it's a current, whether it's a voltage, when anything we are varying, that is that will be in the electrolyte only. Okay, and the ionization is also takes place in the electrolyte only. Okay, so we are assuming that nothing will be lost, whatever the energy that we are generating, that will be completely absorbed by the electrolyte. Okay, so we calculated these two things last time, that is the heat generated, that is v into I you can write, or v is, as I said, that v is very less we are taking. So in term on behalf of this v, you can just write r. So when you will place the r, that will become I square into r. Okay, and the heat absorbed by the electrolyte, that is given as simply like mcp dt, and that I had discussed this one. Okay, that is what is the mean value of m that we have to take, what is cp, that is specific heat, and what is the change in temperature. Okay, after that we discussed the last one, that is a feed rate. And feed rate is nothing but that if this is a tool, then we are giving a feed to the tools towards the workpiece side. So how much distance we are covering per unit time, so that we calculated through the material removal rate upon the surface area or cross sectional area. Okay, so material removal rate, that will be calculated in cc per second, and the cross sectional area or surface area, that will be in centimeter square we can say. Okay, so that will be like centimeter per second. Finally, find that how much amount of the length distance we have to travel per unit time. Okay, so this is how we can calculate the feed rate. After that, in the last lecture, we discussed about one of the problem, okay, that is asked in the gate 2009, and every one of you has, I think, has participated, but few only answered. So today also we are continuing with the numerical part. Okay, so I think I have two no, I have two problems. Okay, so three problems. Okay. So today we have a three problems, but let's see. It depends on you guys. So when you will answer, we'll move to the further. Okay. So I'm just reading this one, and I'm just briefing you about the data. Okay. I will also brief you that what the process that we have to follow, means what approach we have to follow, and just put that values into the approaches and get the answer. Okay. So let's start. So till now, guys, in the previous two lectures, if you have any doubt, you can ask me. I'm giving you 1 minute. So that previous whatever that concept that we have discussed, it should be clear to you. If you do not have any doubt, I'm assuming that one. Okay, and please keep your calculators with you, guys. So I can randomly ask you that what is the answer that you are calculating, guys. Please ready with your calculators today. Last time only 3 to 4 students were participating in the answering, but this time I will ask random one. Okay, no doubt. Then we are proceeding. Okay, guys. Okay, so the problem is from the book only. The electrochemical machining of an iron surface, that is 25 by 25 means the surface area is given to you. So I am just writing the whatever the data that is given to you, that is value of S is given to you. Okay, and that is 25 into 25 square. Okay, guys. Next is in the iron surface, that is 25 by 25 in cross section, using NaCl in water as electrolyte. Okay, so that we have already discussed that we are using here, basically the electrolyte is the salty water. Okay, now the gap between the tool and the workpiece is 0.25 so the minimum gap is, that is small h value is given to you, and that is 0.25 Okay, guys. Next is the supply voltage is 12 volts. So the V value of V is given to you, capital V, that is 12 volts. Okay. A specific resistance of the electrolyte is 3 ohm into centimeter. So small r value is given to you, that is 3 ohm into centimeter. Okay, guys. Next is the estimate first the material remole rate. Okay, the MRR we have to calculate. Next is the feed rate. Okay. Next to that, that is a electrolyte flow rate. Okay, that we have to calculate. On behalf of that, what is given to you? That is specific heat of the electrolyte is given to you, that is 0.997 calorie per gram degree centigrade. The ambient temperature and the electrolyte boiling temperature is given to you, and the density of the material, which is if it is a iron surface, so the density of the iron is given to you. Please keep in mind that is rho Fe. Okay, that is density of the iron. Now, first of all, what we have to calculate, that is the material remole rate. Okay, so it is a simple material. There is no alloy. So what we can how we can calculate this one, that is material remole rate. How we are writing this formula, that is MRR. Now please confirm that what is the unit that we have to calculate, whether it's a gram per second or volume in terms. If you will see this one, then that is in kg per second, or like gram per second we can calculate, or once we can calculate the in gram per second. So after that we just have to convert that. Okay, so means we do not have to take into consideration of this rho. Okay, guys. So if we do not have to take consideration of this rho, then this the, equation will be like sorry, the formula will be I into A upon F into V, small v. Okay, so this I is basically the ampere, which is a current. A is the atomic weight of the iron. F is the Faraday's constant. So if it is not given to you, then we will consider it as a 96,500. Okay. Now, V is basically the valency. So atomic weight and valency is not given to you, but this thing we have already discussed in the previous question, that A is basically the atomic weight. So atomic weight of iron. So the value of A will be equals to 56, and the valency of the iron is 2. Guys, if this data is not given to you, but please remember for the iron especially. Okay, so this is easy to understand. Okay, or easy to do the numerical problems. So now a, that is atomic weight, is known to you. Okay, valency is known to you, F known to you. So we don't know the value of I. Is it given to you? No, it is not given. Okay, but on behalf of this, the voltage is given to you. Okay, so can we get the value of I using the voltage? Yes, we can calculate. That is V equals to I equals to V by R. Okay, sorry. If you will see this one, then I will be equals to V by R. Okay, so voltage is given to you guys. Okay, but the resistance is not given to you, the gap resistance is not given. So how we can calculate this gap resistance? On behalf of this gap resistance, the specific resistance of the electrolyte is given to you guys. Okay, and H and S is given to you. So we know the formula, that is gap resistance, that will be equals to small r into H by S. Now here R is given to you, H is given to you, and S is given to you. So just put the value and get the value of R. Get the value of R and put the value of R over here. Get the value of I and put the value of I over here. Okay, and get the value of material remole rate. So just let's consider. First, we are calculating the value of capital R. So that will be equal to small r into H by S. So now small r is like how much? That is 3 ohm into centimeter. So 3 ohm into centimeter. Okay. Multiply by H. H is how much? That is 0.25 mm. 0.25 mm upon this is like that is also in 25 into 25. Okay, so cross sectional area. But guys, again the same thing that was asked in the last problem, because this up to the material remole rate, this is the same problem you have gone through the last one. Okay, so this is the same thing. So now here this cross sectional area is given in mm square, this is in mm, and this is in ohm into centimeter. So better, it would be great that we should convert this into the mm. Okay, ohm into mm. So when you will convert this centimeter into mm, so this will become 30. Okay, so now guys, please tell me the value of R.
0.01.
0.012.
0.01. Okay guys, 0.01. This will be in ohm. Okay, so let me check the value. 0.01 guys.
Yes, sir. 0.012.
1 2, okay, right, Ibad, right, that is 1 2. I did not listen the 2. Okay, so this is like 0.012. I hope Danish, you are also getting the same value.
Yes, sir.
Okay. Malik Musharraf. Now you have to calculate the value of next. That is, you have to tell me the value of next. That is, now what we have to calculate. R is already calculated. Now we have to put this R value over here. Okay, so from here we can calculate the value of I. That will be equals to V by R. Okay, so V is how much? That is 12 volt. Okay, upon R, that is 0.012. Can you tell me, guys, the value of I from here?
1000 amperes.
1000 ampere. And Malik Musharraf, ME 1732, can you tell me what the value that you are getting? Guys, if you will not
Sir, it's
respond, then
1000.
I should consider it as absent only.
Yes, sir, it's 1000.
It's 1000,
Yes,
but
sir.
I am getting something different.
No, sir, I am getting 1000.
You are getting 1000. Okay, that's great. So now, guys, here you have calculated the value of I. Now what we have to do, we just have to put this over here. Okay, so from here you will get the value of material remole rate. That will be equals to I into A upon F into V. Okay, so this I is the current, that is you calculated, that is 1000 ampere. A is the atomic weight, that is 56, and F is the 96,500. Okay, and V is the atomic weight. Guys, tell me the value of MRR from here.
0.290.
0.290. Anyone please confirm this one. Now, Aman, what is the unit? Unit is the important criteria.
So wait a minute, let me check the
Yeah, sure.
units.
Amir Manzoor, what is the what is the unit that you are getting? What is the value that you are getting? Amir Manzoor, 1821.
Yes, sir.
Yes, what is the value that you are getting?
Sir, 0.290.
But I am getting something different.
What, sir? ये आ रहा है, sir.
Yeah, what is the unit of this?
Can the units be? I think it's grams per second.
Yeah, right. And Amir, what the unit will be there?
Gram per second.
Why it is not kg per second?
No, sir.
Okay, because why it is not kg per second? Because I told you guys that is because that is the basic unit. Okay, because what the things that we calculated, that is mass per unit time. Okay, and the mass that we considered in the beginning, that is in gram only. Okay, so and t is we consider in the second. So whatever the value that you will get it from here, that will be in gram per second only. Okay, so if for an example, if you want to convert that into kg or cc or meter cube or cube, so after that you can convert, but this is a basic value, so that will be in gram per second only. Guys, anyone can confirm me that is it the right value?
Yes, sir.
Okay, actually I am also getting the same value, that's, but I just want to confirm that whether I am also getting the right or something wrong is there. Okay. Okay, guys, but this is not the answer. You have to calculate this material remole rate into kg per second. So what you have to do?
Divide by 1000.
Divide by 1000. Very good, Ibad. This is, so material remole rate will be equals to like 0.290 into 10 raised to power minus 3, or you, when you will, either you can divide it or simply I can just multiply 10 raised to power minus 3. So this will be the value in kg per second. Okay, guys, so this is the fast answer. Okay, now the second what we have to calculate is we have to calculate the feed rate. Okay, and what the formula for that we have gone through, that is feed rate, that is Fr will be equals to material remole rate MRR upon the surface area. Okay, S. So now the material remole that rate we have calculated, and we know the surface area which is given to you, that is 25 by 25. Can we calculate directly? Can we put this value, that is 0.290 into 10 raised to power minus 3 upon the surface area? Can you tell me, guys, what is the value that you are getting from here?
So 4.64 into 10 to the power minus 7.
4.64
64
into 10 raised
into
to
10
power
to the power
minus
minus 7. 7.
minus 7. So what is the unit, Aman?
So units will be mm per minute, I think.
Mm per minute. Why? Because we have to calculate that.
Yes, sir. We have to calculate in mm. Yes, sir.
But this, Aman, tell me this value that you have calculated by using this one.
Yes, sir.
But now, okay, anyone, guys, please cross check this value.
The value is correct, but we have to convert it into minutes because material removal rate is in seconds.
Okay. So here you have to divide by
Yes,
60. Ibad,
60.
is it like
Yes.
that?
Yes, sir.
Okay. Anybody else, guys? Adil Rashid.
Yes, sir.
Yeah. Can you tell me the value that you are getting? This one is it the same value?
सर मैं सॉल्व कर रहा हूँ 1 minute सर.
Okay. Take your time. Junaid Bhatt, ME 1834. Junaid, ME 1834. What the value that you are getting? You are not audible to me.
Sir, 4.64 in 10 to the power minus 7.
Is it right? Now, guys, Aman and Ibad, that you initiated this answer, so please tell me. Guys, I am expecting the answer, Aman and Ibad, from you guys. You just tell me that you both are saying that this is the value that is in mm per minute, or Ibad little bit has changed that you have to divide because that here you calculated in kg per second. So we will just divide it by the 60 so that we will get the value in minutes, mm per minute. But how you are getting this mm from here, guys? This, if you will see the unit of this, then this is not mm cube. This
Yes,
is
sir. It's in
kg.
kg.
This
So
is
should we use
kg.
density in this then? Do
Exactly,
we have to
guys.
use density?
Whatever the value of MRR that you are getting, you have calculated here. Okay, that is in kg per second. But here, if you are putting this one, then you have to convert that into mm cube. Okay, then only it will be in mm square. So this will
Yes,
become mm cube per second, and this will be cancelled out. And finally, like you can divide here by 60, so that you will get in mm per minute. How directly
yes,
you
sir.
can
Yes, sir.
multiply or divide the formula? So next, so what you
Yes,
have
sir.
to do is. Okay, guys. So what you have to do, you have to calculate the feed rate that will be equals to MRR upon the surface area, that is S. Okay, so the MRR that you are getting, that is like 0.290 into 10 raised to the power minus 3. So if you want to convert that into mm cube per or meter cube per second, then how we can convert? Okay, let's okay, guys, what I'm doing is first I'm calculating the material removal rate. Okay, so MRR will be equals to, that is 0.290 into 10 raised to the power minus 3 upon rho. But rho is of what? That iron. Okay, so Fe. Okay, so now iron rho is how much? This is given to you guys. That is 7860. Okay, so but that is in, so this is in kg per second, and that will be in kg per meter cube. Okay, so this is 0.290 into 10 raised to the power minus 3 upon how much? That is 7860. Now whatever the value that you will get, that will be in meter cube per second. Okay, guys, so now what you can do is either you can convert this into cube. Okay, or when you will, because that will be good for you, that you can directly take there in square. Okay, or what you can do is whatever the area that you will take, that you can convert that into meter square. So anything can be done. Okay, so first of all, guys, tell me the value of this, how much you are getting.
Sir, 3.689 into 10 raised power minus 8. 3 minus 3.
3.689 into 10 raised to power
Into 10 raised
minus.
power minus 3.
नहीं -8 ही आएगा, -8 ही आएगा.
Sir, sorry, sir, 8 है, 8 है.
Minus 80 है, I think.
जी सर 8 ही आएगा.
Yes, sir, 8 है, minus 8.
This is minus 8. Very good, guys. So that is in meter cube per second, okay? Yeah, I'm also getting that is in meter cube per second. Okay. So now what you can do is, guys, either you can convert over here, that is in cube. So 1 meter, I'm just writing for the students, those who don't know, that is 1000 okay, or right. So if this is 1 meter, so cube, so that will be into 10 raised to power 9. Is it okay, guys? So this will be like 3.689 into 10 raised to power minus 8 into 10 raised to power 9 cube per second. Okay, so this will be like 10 raised to power minus 8 to multiply, and this 10 will be remaining. So like this 36.89 cube per second. Is it okay, guys? Is there any confusion in this one?
No sir.
Okay, thank you. So this is the material removal rate that we calculated in cube per second. Okay, so now here you can calculate the FR. So this FR will be equals to material removal rate, that is 36.89. Okay, that is in cube per second. Okay, and upon the surface area, now the surface area is how much given to you? That is 25 into 25, and that is in so directly it will be in square only. Okay, so this is 25 into 25, but what feed rate you have to calculate in per minute. Okay, so here, like if you will see, then this will be in square, so this will be cancelled out, and finally you will get whatever the value that you will get, that will be in per second. So what you can do is, this is second, so you have to replace this value. Okay, so 1 second, 1 minute will be equals to how much? That will be equal to 60 seconds. So this 1 second will be equals to 1 by 60. So just 36.89 into 60 upon 25 by 25. Okay, can you tell me the answer of this, guys?
9.837 into 10 to the power minus 4.
9.837 into 10 raised to
into 10
power
to the power minus 4.
minus 4. Okay, that will be in per minute. Please, guys, confirm this value. Aman, did you tell this answer?
Yes sir.
Sir, I am getting 3.54.
Exactly. Mohsin.
Yes, sir, 3.5414.
सही में मैं रीचेक करता हूँ फिर से सर.
Aman, you please check. I'm also getting like 3.54.
3.541.
41 exactly. Very good. This is I'm also getting. This is 3. Yes, Zunaid. This is 3.541. I'm also getting. Okay. So Aman, you please check this answer. So this is the feed rate that we are getting. Okay, guys. Not this one.
Yes sir, it's 3.54. Yes sir. Sorry,
Okay, guys. It's okay. It's okay. Adil, how much you are getting? Majid?
Yes, sir. Yes, sir.
Adil, how much you are getting? Majid, are you there?
Yes, sir.
Yeah, you are not saying any answer today. What happened?
सर मैं थोड़ा बीमार.
बीमार हैं तो मतलब बीमार है तो बेड में ही होंगे ना माजिद?
Yes, sir.
बेड में क्या दिक्कत है? आप कैलकुलेटर तो
So
उठा ही
last
सकते
lecture
हैं.
पूरा मेरा last lecture मैंने नहीं देखा पूरा, so that's why.
Okay, ठीक है. Okay, guys. So this is the feed rate. Now, next, what we have to calculate, that is third parameter, which is the okay. So next is like we have to calculate the value of the electrolyte flow rate. Okay, so flow rate was what we discussed, the flow rate that is in the flow analysis part. So in the flow analysis part, the heat which is generated, okay, that is given as like Q into rho of the electrolyte into C of the electrolyte into TB minus T naught. Okay, but so from here basically we can calculate the value of Q, that is a electrolyte flow rate. Okay, so that will be in centimeter cube per, so that we can see. Okay, there is no issue, but the heat which is generating, that value is not given to you. So what we can expect, that if nothing is given to you in this problem, then we are considering that whatever the heat that is generated, that will be completely absorbed, sorry, this is absorbed heat. So this is completely absorbed by the electrolyte. So what is the heat generated? That will be equals to Hg, and what is the value of that is I square into R. So let's see what is the data that is given to you guys. Okay, so first is like I, that is the current. So current we have already calculated in the first part. R, that is resistance, that also we have calculated in the first part. TB, that is boiling temperature, and the TO, that is the atmospheric temperature or ambient temperature. So this boiling temperature is 95 is given to you, and the ambient temperature, that is 35 degrees centigrade, is given to you guys. Okay, next is the CE, that is the specific heat. So the specific heat of the electrolyte, that is 0.997 calorie per gram into degree centigrade, that is also given to you guys. Okay, so CP is not an issue. Now if we talk about the rho, then we have to calculate this value, and sorry, Q we have to calculate, and rho E is nothing but the density of the electrolyte, Okay, so let's just check whether this value is given to you or not. So the density of the that is 7860, that is only given to you in the beginning. So that is basically the density of the iron. So if it is not given, then please consider that if we are using the this is salty water, for that the density of the electrolyte in that case will be equals to 0.10 gram per cc. Okay, so please keep in mind this one. Now you can calculate the value of this. Sorry guys, please check it here. It is not 0.10, it is 1.0. It is 1.0 gram per cc. Okay, so means the value of 1. So now from here you can calculate the value of Q. Okay, so let's select the another page. So now from here the equation will be Q into rho E into CE into TB minus T naught, that will be equals to I square into R. Okay, so now from here you can calculate the value of Q, that will be equals to I square. I square is how much we calculated, that is 1000 ampere, and the value of R, that is 0.012. Okay, so like this will be like 1000 square into 0.012 upon rho E. Rho E is how much? That is 1.0 gram per cc. Why we are considering that into gram per cc? Because that is also given to you, that is in calorie per gram per cc. Okay, centigrade. Okay, so that will be like how much the value of CE. CE is 0.997. So that will be like 0.99 into 7 into TB minus T naught. TB is how much? That is 95 and T naught is 35. Okay, so that will be like 95 minus 35. Okay, so guys, can you tell me the value of this?
$200.6.
200.6. Guys, please concern 200.6. That will be in cc per second. Okay, because why it is we are directly taking that into cc per second, because the density is already given to you in cc. Okay, gram per cc. Okay, and and whatever the value that you are getting over here means that is either it should be in watt or joule. This watt and joule will be directly proportional to this watt or joule. Okay, so whatever the value that you are getting, that will be in cc per second only. Please keep in mind that one. Guys, is it please confirm, is it fine?
Yes, sir.
Yes, sir.
Okay. I think it's mine is wrong. Okay, guys. So if you have any, yes, Ibad, please ask.
No, sir.
Okay. So, guys, any one of you have any doubt, you can ask me. Then, otherwise, we'll proceed for the next problem. Suhail, are you there? ME LE 1855. Sohail, I mean rather, ME LE 1855. Are you there? Najmus 1809. Are you there? Numan, Numan Ramzan.
Yes, sir.
Are you there?
Yes, sir.
Do you have any doubt?
No, sir. No, sir.
Okay. These two are sleeping. Okay. Okay, guys. So let's move to the next problem. Okay, guys. So this is the wonderful problem, guys, that has been asked previously in GATE examination in 2008. Okay, because that exam, GATE 2008 examination was conducted by IIC Bangalore. So if you will see the whatever the problems that has been asked in 2008, all the problems, not these problems only from the manufacturing, but from all the subjects, the problem that means the level of that question paper was very one's quite good. Okay, other than what the IITs are asking nowadays. Okay, in which students are getting 100 out of 100. So that time it was very I think when this paper was there, very less cutoff was there. Okay. So let's go for a problem. That is, a researcher conduct electrochemical machining on a binary alloy. Okay, so now guys, here it's not a single material. Binary alloy means the alloy is there. Binary means there are two elements. Okay, please consider. First, look at the what the data is given to you. So binary alloy, the density of this is 6,000 kg per meter cube. Please let me explain, guys, what is the meaning of that. That is MRR, that is material removal rate. If I'm writing in terms of the density, in terms of the volume, then it will be like I into A upon rho into F into V, that is density. Okay, sorry, valency. Now this is basically the density, and this is basically the equivalent electrochemical equivalence. Okay, so this is A by V, but this is a binary alloy, but it is mentioned that density of that binary alloy is 6,000 kg per meter cube. So the meaning is, like, if you when you will calculate the material removal rate, there may be a possibility that you will get like I into how we are calculating for the alloy, that is I into E equivalent upon rho equivalent into F. Okay, but here the density of these two elements, the elements are there, means which is a combination of the alloy, which is a combination of two materials. The different densities is not given to you, but as combined density is given to you. So the value of this this rho equivalent, and this will be equals to 6,000 kg per meter cube. Okay, guys. So this is the meaning. Okay, of iron. Okay, let's again. Researchers conduct electrochemical machining of a binary alloy. Okay, of iron. The first material is the iron. Okay, the atomic weight is 56 and the valency is 2. Okay, and the metal P means there are two metals. First is the iron, and second is the which is a random material, which is P. Any name they are giving. Okay, and for that the atomic weight is basically 24 and the valency is 4. Guys, I just want to brief you that what is the meaning of this, that if you will talk about here the means here we had discussed about this rho equivalent. So rho equivalent is directly given to you, that is the density of the binary alloy, that is 6000 kg per meter cube. But here the value of E equivalent is not directly given to you, means it's not like a combination of what is the atomic weight of the binary alloy or what is the valency of this binary alloy. That cannot be, nobody can tell these, okay, because everybody, whatever the all of you are aware about the periodic tables, okay, so whatever the elements are there, we can define the atomic weight and the valency for these only. If we are making some another binary alloy or tertiary alloy or any kind of alloy, then for that atomic weight and the valency cannot be defined, okay, we cannot calculate that one because there is nothing is available for that, okay. So whatever the elements are there, individual elements, we can define this atomic weight and the valency for them only, okay guys. So here please do not think that the atomic weight, single atomic weight and the by the using the single valency we can calculate this E equivalent. No, no, for that, if it is the binary alloy is a combination of two different material, then two different value of A and V is required, okay. So that is also, that is given to you, that is atomic weight for the iron, which is the first material, atomic weight of P, that is 24, which is a P material, so second material, and the valency, that is 2 for the iron, that is the first material, and the valency 4, that is for the second material. That is given to you guys, okay, please do not confuse. Next is the Faraday's constant is 96,000 coulombs per mole is given to you. The volumetric material remole rate of the alloy is 550 mm cube per second, okay, at a current of 200 ampere. So from here, like this is like, if I am considering that this is the first material, which is iron, and this is the second material, okay, so that this will be like first material, A1 is given to you, that is 56, and with respect to V1 is given to you, that will be equals to 2, okay. A2 is given to you, that is 24, and V2 is given to you guys, that is 4, okay. Now F, capital F is given to you, that is 96,500 coulombs per mole, okay, and the volumetric remole rate of the alloy, that is we can say that is material remole rate is given to you in terms of volume, so that is 50 mm cube per second is given to you guys, okay, at a current, that is I will be equals to 200 ampere, sorry, 2000 ampere, okay. What we have to calculate, the percentage of the metal P in the alloy is closest to. So closest to means there will be whatever the value that we will get, that is the approximate value. So just we have to find out the closest value for that, okay guys. So how we will proceed, we know this formula, okay, that material remole rate, and here the material remole rate is given to you guys, I is given to you, F is given to you, density is given to you, but for this like chemical equivalence, so we just have to calculate this E equivalence value and put it over here, then we will see that what we have to calculate, okay guys. So first let's try this one. First okay, let's calculate this value because all the values is given to you. So first we will get this value and then we will put this value over here in this formula, okay. So now we have to calculate this E equivalence. So either we can take like directly we can means we can use this 100 over here, or I'm just using one only, okay. So whatever the value that we will get, that will be in points, okay. So just multiply that with 100. So like this value, this will be equals to E1 by E equivalence, that will be equals to x1 upon E1 plus x2 upon E2. As this is the first problem, that's why I'm going in detail, okay. So that will be equals to x1, and E is what, A by V. So when you will just replace that one, that will become V1 by A1 plus x2 into V2 by A2, okay. Now here we don't know the value of x1, which is the first component metal, that is iron, and we don't know the value of second x2, but we have to calculate this value, okay. So like if this binary alloy, which is a combination of two elements, so can we say like x1 and x2, if we are taking in points, then it will be equals to 1. if we are taking in percentage, then it will be equals to 100, because जो भी weight होगा आपका material का, that is the combination of these two only. So if we are saying that this is 50%, then what is remaining? That is 50%, so that will be equals to 100. Or if I am saying that this is 0.50, then how much this will be? This will be again 0.50. Okay, so from here, what we have to calculate? We have to calculate the percentage of metal P, means we have to calculate the value of x2. Okay, so just replace this x1 by x2. Okay, so from this one, from this equation, x1 will be equals to 1 minus x2. Okay, so just put this value over here. Okay, so this equation will become 1 minus x2 into v1 is how much? That is 2 upon a1, that is 56. Okay guys, and here x2, so and v2 is how much? That is 4 upon 24. Is it okay guys? If I am somewhere wrong, please correct me guys. Okay, so just okay, what you can do is either like if you will, like guys, if you will multiply this 2 by 56 inside, okay, then it will become 2 by 56. Okay, and minus 2 into x2 upon 56, and this will be 4 into x2 upon 24. So now both the terms are of x2 only. Okay, so what you have to do after that, because you have to take the LCM and then you will calculate the value. So just directly here calculate the value of 2 by 56. So just multiply this value here, get the value of 4 by 24, just multiply with x2 and then you calculate. So please tell me the value of 2 by 56, how much you are getting?
0.03.
0.035.
Just a minute guys, this is 1 minus x2 and this is 0.035. Is it okay guys?
Yes, sir.
Okay, and this will be x2 into 4 by 24. This is how much?
So 0.16.
0.16. Okay guys, so this will be like, when you will multiply this 0.035 inside, so this will be like 0.035 minus 0.035 into x2. This is x2 plus 0.16 into x2. Okay, so okay, so this is the value of 1 by E equivalent. So that will be equals to 0.035. Can you tell me this one, that guys, 0.16 minus 0.035, how much you are getting?
This is 0.19.
Minus 5.5.
Sorry,
195.
0.195. Is it okay guys? Okay, so like this is the value of E equivalent, 1 by E equivalent. We have to calculate this E equivalent value. So can I take all this value towards this side and cross multiply? So when you will cross multiply, this E equivalent value will become 1 by
It's
0,
0.125, I think. So it's minus, I didn't see the minus. It's 0.125.
0.125. Guys, that's why I'm asking. Please cross check. Okay. Yeah, it's 0.125. Ibad, have you left or?
Yes, sir.
Please confirm this value, guys.
Okay, sir.
Actually, that when you will answer, na, like it will just cross check to me. Okay, it's not like because I have calculated this value, but I'm not sure that whatever the value that I have calculated, it is right or wrong. Okay, because I sometimes I not believe in my own calculation. Okay guys, so this is how much you are getting, that is equivalent value, that will be equals to 1 by 0.035 plus 0.125 into x2. Okay, so this is the value that I'm getting. Okay, so just put this value over here. So let's take a new page. So this will be equals to like material remole rate will be equals to I into E equivalent upon rho equivalent into F. Okay, so the material remole rate that is given to you, how much? That is 50 mm cube per second. Okay, so just write this is 50 mm cube per second. That will be equals to I, that is how much is given to you, that is 2000 ampere. Okay, so this is 2000 Okay, and E equivalent value is 1 by something, so this will be like 1 upon this is 0.035 plus 0.125 into x2.
Sir, this is minus 0.125 x2.
This is minus. No, I think
नहीं,
this
minus
is
नहीं आएगा.
no.
Minus नहीं
It should not be minus, Aman. I think it would be
Yes, sir,
plus
minus
only.
नहीं आने
Reason
का.
is
Yes, sir.
क्योंकि
Plus है.
0.16 बड़ा है
Yes,
ना
yes.
इससे.
yeah, exactly. This
0.16
0.16 value is greater than 0.035. So whatever the value that you will calculate, that will be in positive only. Okay. So this is okay. So this is the E equivalent value. E equivalent is how much? That is 6,000 kg per meter cube. Okay. So this is 6,000 kg per meter cube. Okay. Into that is F value is how much given to you? That is 96,500. Okay. So this is 96,500. Now guys, please confirm that this value which is given to you in higher MRR, because now in this formula, now we have kept the value. So here except this x2, everything is the unit only, means number only. So now we can calculate the value of x2, but before calculating the value of x2, you just have to cross check the units. Okay, because here this MRR is in the mm cube per second. This is in mm cube per second, and when you will see this one, this is a density that is in kg per meter cube. Okay, that is in kg per meter cube. So you just have to convert these values. Okay, so when you will convert this one, like how much you have to do?
6 gram per cc.
6 gram per cc. Have you converted that meter cube? Guys, because this material removal rate is what?
हम
This
इसको
is
kgs में ही रख सकते हैं ना. हमें शायद meters को mm में convert करना होगा या mm को meters. kg में हम रख सकते हैं.
yeah. First of all, what you have to do is, first of all, that is you have to see that this is meter cube. Okay, and this is mm cube. So what you have to do is either you should convert this value into meter cube, or you should convert this value into mm cube. So it's up to you guys. Better it would be great, like here you will be anything you can do. Okay, so I am doing like this is 50 mm cube per second. So when you will convert that into meter, so 1 meter will be equals to 10 raised to power minus 3 meter. Okay, so what you have to do is you just have to write that is 10 raised to power minus 3 cube, so it will become minus 9. Is it okay, guys?
Yes, sir.
Okay, now here one more thing is there, that whatever the value that you initially you were calculating, that was in gram per second, right? That was in gram per second, and the density that you use there, that was also in gram per cc. Means when we keep this formula, so this gram will be cancelled out, and this will become, this equation will become in cc per second. So now that depends that this MRR, if it is given to you in cc per second, so we can calculate, we can take this value in gram per cc. But here it is given to you that is in mm cube per second. So we just have to convert it that as per the requirements, that is kg per meter cube. But this is the density that is in kg. So what you have to do, you have to convert that into gram. Okay, so when you will convert that into gram, so this will be like what you have to do, 10 raised to power minus 3 or 10 raised to power 3.
So किधर पे?
Here basically you have to multiply, because this is in kg, this is in kg per meter cube. Okay,
Yes, sir.
so like for to balance this meter cube, you have converted this mm cube converted that into meter cube per second. Okay, now this unit towards the left side, this unit become meter cube per second. Okay, but when
Yes,
you
sir.
converting that into volume, in terms of the volume, that time it should be in gram. This is kg here. Okay, so it should be in
So
gram.
why
So
it should be in grams? Sir,
why it should be in
ये
gram?
तो मतलब yes, sir.
Because
मतलब ये तो weight
initially
का unit है ना ये भी.
that is a unit of weight only, Aman. But when you calculated this material removal rate in the beginning, that time I
अच्छा
told you
मतलब
that is
यूनिट
a
हिसाब से यस सर ठीक है आ गया समझ यूनिट हिसाब
because
से
because here
Okay, sir.
that is you are taking that is in mass, and that mass is depend on I A upon F into V. Okay,
Okay, sir.
so you cannot calculate these value
स्टैंडर्ड यूनिट्स के हिसाब से स्टैंडर्ड
exactly as per these units, that is ampere or this is coulombs per mole. On the basis of that, whatever the value of mass that we are getting units, that is in gram. Okay, accordingly. So now if you are taking this density over here, then you should convert this into the gram if it is given in kg. So what you have to do, you just have to multiply with the 10 raised to power 3 or minus 3.
-3.
-3.
ओनली 3 10 to power 3
Guys, if it will be -3, then आप उस वैल्यू को रिड्यूस कर रहे हैं,
रिड्यूस कर रहे हैं हाँ हम ग्राम में कन्वर्ट करना है ना
अगर
इसको इसलिए
केजी
बढ़
में है
जाएगा
आप उसको लेस क्वांटिटी में लेके जा रहे हैं तो वो वैल्यू बढ़ेगी, इंक्रीज होगी. सो इफ इट विल इंक्रीज, तो इंक्रीज कब होगा, जब आप उसको 10 टू पावर 3 से मल्टीप्लाई करेंगे.
सर ये रिपीट कीजिए फिर से.
Guys, here why we are taking this is density is given to you, that is in kg per meter cube. ठीक है. Now here it is, this value is given to you in meter mm cube per second. So what you can do is, first of all, we are balancing this meter cube, okay, or mm cube volume terms. So what you can do is, either you can convert this meter cube into mm cube, ठीक है, or either you can convert this mm cube into meter cube, ठीक है. So I have converted this, I have just multiplied 10 raised to power minus 3, 10 raised to power minus 3 raised to 3. So this will become 10 raised to power minus 9, and that become meter cube per second in the right hand, in the left hand side. Okay, so now this unit become meter cube per second. Okay, first one. The second one is, when you are calculating here this material removal rate in the beginning, that formula we derived, that time I mentioned that please keep in mind this unit of this mass, that is in gram, that is not in kg, because whatever the ampere current that we are using means as per the unit of these ampere and the coulombs per mole, on the basis of that the mass unit will be in gram only, it should not be in kg. अगर मान लीजिए आपको kg में given है, then you should convert that kg into the gram only. Okay, so now here this density is given to you in kg per meter cube. So meter cube is now satisfied with this mm cube. Now we have converted, we have sorted out that issue. Now but still this kg is remaining, so you have to convert that kg into the gram. Is it okay, guys?
Yes, sir.
Yes, sir.
Good, great. So now just we have, and like 1 kg, 1 kg equals to 10 raised to power 3 gram, because gram is basically the small quantity, kg is a large quantity. Okay, so when we are converting that kg into gram, so you have to multiply by the 10 raised to power 3, because it will increase the quantity, it will not reduce the quantity. Okay, so now we have multiplied it. Now please, I'm just a little bit, I'm just making this equation simplex to you guys. So I'm just taking this value towards the left hand side, and rest of the value in the right hand side. Okay, so this will become 0.035 plus 0.125 into x2. Okay, that will be equals to 2000 upon that is 6000 into 96500, sorry, 96, this is 96500 into 10 raised to power 3 into this value, that is 10 raised to power minus 3 into 50. Okay, so this is 10 raised to 50 or 10 raised to power minus 9, so you can make it over here, so this will become 10 raised to power plus 9. So guys, can you tell me the value of right hand side, that what you are getting? Please calculate this value. Okay, right hand side, in the right hand side what you are getting. So I am writing this left hand side, that is 0.035 plus 0.125 into x2.
सर ये आएगा शायद 1 divided by 14.475
No guys, Aman, please tell me the clear value, that is in points, that you are getting.
zero 0.069
0.069. Guys, please confirm. Adil?
Yes, sir. ठीक है.
Okay, Umar. Adil, you should also confirm. ME
यस सर
1808.
ठीक है
ठीक है?
यस सर
Okay, guys. Okay, guys. So just take this value, that is 0.035 towards the right hand side. Okay, and this will be like 0.125 into x2. So this will become 0.069 minus 0.035. Can you tell me this is how much you are getting over here? That is, I think this is please
0.034.
0.034. Okay, guys. So x2 value. Now, can you tell me the guys x2 value? That is 0.034 upon 0.125. Can you tell me the value of this?
0.272.
0.272.
0.272. Anybody else? Please confirm.
0.0272.
सर ठीक है.
Okay.
0.27.
Okay. So this is guys, this is the value of x2, means the percentage of the metal that we are taking into consideration. The value of that one is this one. Okay. So this is like in percentage value, means this is in uh, elemental value. If you will convert that into percentage, then this will become just multiply with the 100. So this will become like 27.2%. Okay. So this is basically the answer. Can we say like, can we check the answer? So this is like closest value we have to find out. Okay, the percentage of the metal P or the metal 2 we can say in the alloy which is closest to. Options are like 40, 25, 15 and 79. So which will be the option? Because
Option B.
whatever the value that we are getting 27, that is not available.
25.
25. 25. Very good
25.
guys. So the option will be B. Okay.
Yes, sir.
So okay guys. So if you have any doubt, you can ask me. There is a one more problem, guys. Guys, please, if you have any doubt, I'm giving you 1 minute, so you can ask me. Okay, guys. Anyone, please take the screenshot of this one. Okay, means from your mobile, you can take the screenshot of this. And by the time I'm taking your attendance.